Objective 3.9, to be able to write the function in standard form based on transformations. Here we have our function k of x. It's a quadratic equation because we can see that it's to the power of 2. We want to take this function and perform the operations on it. First, we'd like to take this function and move it to the right 2 units and up 4. When you're looking at transformations, you should always ask yourself, is it an input change, output change, or both? We know that going to the right 2 units would be an input change. And typically, we write the representation for going to the right 2 units by using x minus 2. Then, when we move something up 4 units, that's an output change, and we would just be adding 4 to our outputs. So we would have a plus 4 to represent that. So we're going to take the input changes and put them into the inputs where it's being affected, and the output change and place that where it's being affected in the equation. So at this point, we just have to follow our order of operations to simplify the function and put it into standard form. So according to order of operations, we should start with our grouping symbols. And within our grouping symbol, we have a distribution of 3 that we can do. So we would have 3x minus 6 minus 1 inside our parentheses. We also have some like terms here on the exterior that we combine. 4 and 4 give us 8. Closer to standard form, but not quite. We can still simplify some like terms within the parenthesis here. We have a negative 6 and a negative 1, which will give us a negative 7. Again, not quite in standard form yet. We have a quantity squared. So we need to take 3x minus 7 and multiply it by 3x minus 7. Some of you like to use a box to help you do that for your distribution. Some of you like to use your arrows to help you. Whatever method works for you, use that. When you take 3x minus 7 times 3x minus 7, we should end up with 9x squared minus 21x minus 21x plus 49. We do have like terms that we can combine. Here are the linears, so we'll have a negative 42x. Almost in standard form. Again, order of operations, we have some multiplication that needs to occur. Take 1/3 and distribute it to each term within the parentheses. So we would have 9/3 x squared minus 42/3 x plus 49/3 plus 8. Here you want to see if there's any more simplifying you can do. Well, 9/3 is 3, so this would be 3x squared. 42/3, that would be a negative 14x. 49/3 we can't simplify, but we know this is a like term with 8. Because this is a fraction, we need to make this a fraction. So we think about this as 8 over 1. When you're adding fractions, you need a common denominator. Since this is in thirds, we need this in thirds. So if I take 1 times 3 to change my denominator, I have to do 8 times 3 to change my numerator. So I would have 24 thirds representing the constant of 8. Because they have the same denominator, I can add my terms together. 49 thirds and 24 thirds would be 73 thirds. We cannot simplify it, so we would leave it as is. So here's our final transformed equation for k. 3x squared minus 14x plus 73 thirds.